Hello and welcome to another video. Today we're going to be continuing on with the Typescript line 75 and we're going to be doing merge k sorted lists. So in this problem you're given an array of k linked lists and each linked list is sorted in ascending order. And you want to merge all of the sorted lists into one sorted linked list and return it. So we have these lists and we want to do that. So there's a few ways to do this essentially. One way to do it would be using a heap, where essentially you put all of your starting nodes of your list into a heap, which would look like, let me just go through that really quick. So let's say our starting nodes is called this like C1 equals 1, C2, and in Python you do have to do a little bit more. In JavaScript you could actually do this. You could literally make a heap with list nodes and then make a custom sorting function, but essentially it would look like C2 1, and then we have C3 2, and then essentially what you would do is you would just always take the min element, and then once you take the min element, like let's say you take this one, then you just update the current node you're on. So like let's say you push this node here, or you pull this node, then you would say, okay, well, does that node have a next pointer? If it does, let's add that node into the heap. And we can keep doing that until our heap is empty, and that would work for us, but we're not going to go through that solution. I just wanted to briefly mention that one. The reason being, in LeetCode, in TypeScript, you can't do like npm installs and imports, so we actually can't import a heap. And so because we can't import a heap, we're not going to use a heap, we're going to use another approach to solve this. So the approach we're going to do to solve this problem is we are actually going to do a divide and conquer approach. And essentially, I'm going to show you what that looks like. So let's say we have our array of, and instead of drawing out these linked lists, I'm actually just going to draw out like a few numbers, and I'll show you what I mean by this. So let's say we have 6 linked lists. We'll just say 3, or you can have 8 linked lists. It doesn't really matter. Okay, there we go. So imagine we have 8 linked lists, and each element in the array is the head of a linked list. Well, in our previous problem, when we merged 2 sorted linked lists, so if we wanted to like merge these two, we could do that by calling that function, and we're actually going to reuse that function. So I literally just like copy pasted that function. And I will show you that in a second. But essentially, let's say we have a function that does that. So what we're actually going to do is we're actually going to loop through this array, and we're going to set intervals, and we are going to try to loop. We're going to merge two linked lists next to each other until we run out of linked lists to merge. So that's going to look like it's like this. We're going to go through this. We're going to take our first 2 lists, and we are going to merge them. And we're going to always store the result in the first index. So we're going to have this here. And then this, I'm just going to write an X, as in we don't really care about it. Like, there will be something, but we don't really care. Okay. And now, for these 2 lists, we're going to merge them as well. So this and this, we're going to merge them with our helper functions. We're going to have 2, and then we're going to have something we don't really care about. And then this 0 will contain this whole merged list. 2 will contain this whole merged list. Then we're going to have 4, then we're going to have X, then we're going to have 6, and we're going to have X. So essentially, this 0... this 2, this 4, and the 6 are our merged list now, where the 0 is 0, 1, the 2 is 2, 3, the 4 is 4, 5, and so on. And then we're going to do this again now. So we're going to merge every 2 lists that we have. So what's going to happen is we're going to merge 0 and 2. So I'm actually going to draw it like this. I'm going to draw it. So this 0 and 1 goes into here. This 2 and 3 goes into here. This 4 and 5 goes into here. And then this 6 and 7 goes into here. Okay, now we're going to take 0 and 2 and we're going to merge those into a list, so we're going to merge them into 0. So now this was an X, this is an X. Now this 2 we don't care about, so X, X, and now we're going to merge these 2 lists with our helper function. So we're going to have 4, X, X, X. Okay, now we have 2 lists left, so we're going to merge those, and we're going to store the result in 0. And then the rest of our lists we're not going to care about. So it's going to be like this. And now, finally, you could also even technically just say, like, you can make them null if you wanted to afterwards, but it's not really going to matter. Okay, so now let's actually think about what we need to do. So now our whole merged list is in here, and all we have to do is actually return this, and that is our entire merged list. And so that's kind of the function we're doing. We're going to be setting an interval, and the first interval will be 1, as in you compare every 2 lists. And then what should the next interval be? Well, it should double. So it should be like times 2, because now they are 2 apart. Then it should double again, because now they are 4 apart, and so on. So you can see how this is going. And then once our interval is too big, like then the next interval will be times 2 again. It will be 8 on this iteration. So here it will be 1, here it will be 2, here it will be 4, and here it will be 8. And then once our number is not smaller than the length of the item in the list, then we're going to say like, okay, well 8 means we take this and then something 8 away, but 8 away is out of bounds. So that's essentially how we do this. We make this interval and we keep doubling it and doubling it and doubling it, and we use a helper function to merge all of our lists. And I would encourage you to, I'm not going to go over it, but I would encourage you to try using a heap, because you have to import a heap, and there's all these cool things you can do with a heap in TypeScript. And I will probably maybe just like import a heap in TypeScript or go over it in like a separate video, because yeah, I tried doing it in LeetCode, and essentially you can't import a heap into the solution. So it kept giving me errors, but you can like import a heap in npm install. And there are a couple of heaps that I looked at, and I'm going to write those down. So I looked at a priority queue, which is a heap, but it's like it's built on top of a heap. Then there's also a min priority queue that I looked at. And then there's also a heap. And for all of these, the nice thing is actually in TypeScript, you can actually define like the kind of values they have. So in Python, you can't have a list node because you need 2 values you can compare. But in JavaScript, you can actually create a custom comparator function. So you can say like my heap will take list nodes, and then I will create a custom sort, you know, kind of like in other sorts where you could just say like, let's take a.value and b.value and let's compare those. So you can actually make like a heap with a custom sort, which is really nice. But the reason I didn't do it in LeetCode, like I said, is because it doesn't work because you can't import it, so it gave me errors. So we're going to be doing this divide and conquer instead, where we're just going to be merging arrays together, and we're going to be looking at that. Okay, so let's take a look at what that's going to look like in actual in VS Code. Okay, and here we go. So I did make a few changes from the past GitHub, which, like I said, I'll keep updating this GitHub, so if you wanted to do these problems, you definitely can. And what I did is, because a lot of these problems used a linked list, like they all had a linked list definition, I just made a data structure called linked list, which is like the standard LeetCode list node, and then I'm just going to be importing it in here so that I don't have to like keep making a new linked list and, you know, things like that. And also I exported all of these functions, and I'm just going to import this function here, merge to list, from the previous problem, because we're going to be reusing that. So if you don't want to do that, you can just write it yourself in this problem. I'm not going to write it myself because this is like the last video we did. And so, but we will be using it. Okay. So what we're going to be doing is we're going to be, like I said, we're making this interval thing that's going to start at 1, because it will be taking 2 nodes next to each other, and then it will keep growing because the nodes are going to be twice as far apart every single time, right? Like if we have, once again, if we have like 1, 2, 3, 4, 5, 6, 7, 8, essentially we're combining 2 nodes every time. So like in the first iteration, these will turn into x's that we don't care about. So now that the nodes that we do care about are 2 apart, in the second iteration, we're going to have this, and now they are 4 apart. So, and then in the third iteration, we will have this where we're just out of bounds. So that's why you need to keep doubling your interval, essentially. Okay. So we're going to just make like a, actually we don't need to do that. So we're going to set this interval. So let's set an interval. And it's going to be a number, but like I said, we don't really need to make it a number because it's TypeScript. Let's see what error we got here. That's fine. Okay. So we're going to say while interval is less than, and then remember it has to be less than list.length, because if it's, let's say it's greater or it's equal to, we're going to be comparing the number. We're going to be comparing an index to another index interval away. So for an index 0, and this is 8 long, then we can't look at index 8 because that's out of bounds. So we're essentially going to do this until we're out of bounds. Okay. Okay, so we're going to make a for loop here, and we are going to do this. So we're going to say this, and then we're going to say I. So I needs to be less than amount plus minus interval, because we're going to take a look at how that's going to work in a second. And then essentially we are going to be increasing it by this, and we're going to definitely do a walkthrough here. So this is our conditions for the for loop, and let's take a look at that with that 1, 2, 3, 4, 5, 6, 7, 8 thing. So if we have this, just do a brief run to explain that a little bit better. So let's say we have 8 numbers. So our interval starts at 1, right? And so this amount actually needs to be list.length. There we go. Okay. So list.length here is 8. So essentially in the first run, I has to be less than list.length minus interval, which would be 7, right? So essentially, because you're comparing every two values, you only need the left value, and then you know where the right value is. So the last left value is the 6, right? We're going to be comparing the 6 to the 7. So we're going to be comparing every two values. So we need this value here. Let me actually write this to make it a little bit more sense as well. So we're going to say list I equals, and then we're going to use this merge to list that we're importing. And then we're going to say list I, and I'm going to explain this part as well. List I plus interval. And the reason for that is because the two lists we're comparing are interval away. So in this first case, the two lists we are comparing are 1 away, so it's going to be 0, 1, 2, 3, 4, 5, 6, 7. But essentially, we need this list I, this one over here. And so this is at index 6. And so 6 is less than 8 minus 1, which is 7, which is right where we want to be. We don't want to do this one because we want the left side of what we're comparing, right? And so if we do that first comparison, then remember our stuff looks like this at the end, or after the first comparison. And now our interval is 2. And so if you think about it, the last value we want would be over here as well, right? So let me double check that. 6, 7, yeah. So essentially here, interval, this length minus interval is I is less than 8 minus 2, which is 6, right? So if you think about it now, that makes perfect sense because we're comparing these two. So we're comparing the 0 and the 2 and the 4 and the 6. So this 6 is not less than 6. So this 6, like once you get to this, you'd be out of bounds. So, but the values you want are this 0 and this 4. And the reason why you're increasing the interval, by the way, by interval times 2, because if you look, you start at the 0, you want to skip the 2. So you don't want to increase it by the interval, you want to increase it by interval times 2, because you want to skip, like we're just getting the left number, and then we're skipping the right number, and then going to the next left number. So essentially, this loop will give you every left index of the two things you're comparing. And then finally, so once you do these comparisons, you're going to have something like this and this, right? And then the next step, the interval will be 4, and then you're going to compare this index to this index, right? Always in I plus interval, there are 4 away. And then finally, this is going to be 4, and so this will be out of bounds as well. So it works out perfectly. Okay. And now what we need to do is we also need to increase the interval here. So remember, interval, we're just going to keep doubling it. Okay, there we go. Okay. But yeah, I will say that with a heap, you actually get a lot more TypeScript practice. So maybe I will just do a heap problem because you have to figure out like type for a heap, which is kind of cool. And like I said, you can make custom sort functions and so on. But because I wasn't able to, put that on LeetCode, I do want to actually like be able to post a LeetCode solution in that will actually work. And that's why you should probably never take a technical interview in TypeScript. But yeah. Well, actually, I think in a real interview, you can probably say like, I know a heap import, and then your interviewer should be okay with you using it. Because essentially, if you want to use a heap, if you think about it, in a problem, designing a heap by itself is probably close to a hard problem. Like it's quite big and not very easy. So this with a heap with designing a heap would be like very tough to code in the amount of time they give you. Okay, so finally we have one more case, and so you can actually get in the constraints you can actually have an array of no lists. So we do want to check like how many lists we actually have. So we're going to check that. So we're going to say if list.length is greater than 0, right? We want to actually make sure that like we have stuff. Then we can return list 0. So remember, our final solution should be in list 0. Otherwise, we can return null if we're given no lists. Okay, let's see. There we go. Oh, so I think we're missing a here. Yeah. But yeah, so the next thing is, yeah, we're just going to import this function. So essentially what this would look like if you didn't import it was, it would be this problem, and then this merge to list, you would just write like a helper function down here somewhere. And then that would be your like full solution. But we're not going to do that because we already wrote it in the problem before. And if you want to watch that, let's actually just like the video before this one, how to do that part. Oh yeah, so let's try to actually run this. And I actually, in LeetCode here, I already pasted that problem we wrote because we can't just like import it. So we're just gonna paste the solution. Let's try it. But yeah, it's also like a cool approach to learn, that a heap. But I mean, I think heap is a lot more intuitive. So you can see it's pretty efficient and it does work. And let's think about the time and space for this one. So essentially, what are we doing? Like every loop. So this merge two lists, how long does that take? Well, it's just going to take n time based on how long, like if these lists are, well, it's actually going to be like m plus n. But if you think about it, every full cycle of merging that we do, right? Every full cycle, like let's say we have lists, whatever. It doesn't really matter, like 1, 2, 3, 4, 5, 6, 7, 8. If we merge every single one of these, that's going to be n time, where n is the number of nodes total. Right, so that's going to be n time, and then when you have the list, even something like this, that's also going to be n time because we're merging the same amount of nodes, right? One will just contain, or it should have a 0 in the front, but so it actually should be 0 like this. But essentially, 0 will contain all the nodes from 0 to 3, and 4 will contain all the nodes from 4 to 7, and so I should get rid of this one. And so it's the same, it's the same time. So every full cycle of merging, essentially every time you loop through this is n time. And then how many total intervals do you have? Well, if you think about it, so if you have like k lists, you're essentially doubling your interval every time, right? So you're like 1, 2, 4, and so on, until your interval is bigger than the number of lists, which is, if you're doubling it all the time, that would just be log k. So every merge is n time, where n is the total number of nodes in all your lists combined, and then it's going to be n log k, where k is the number of arrays you have, like the number of total lists you have. Okay, and for the space, what are we doing? So we're actually doing this in place. We technically are taking up a little bit more space. I think we're, because essentially, let's say, I guess what you could do in this if you wanted to, so you could say, let's do this, and then you could say, if you wanted to clean it up a bit, I guess, you could say, but it's still going to be the same time, right? So you could say this equals none or something, or null, and I believe that should work as well if you wanted to, but it doesn't really matter because you're essentially never touching that list again. So that would work as well. It should give you a little bit more space on LeetCode, but it's the same solution essentially. Okay, so you can see it's more space, but essentially, space complexity, it's going to be the same thing. Okay, so let's think of the space complexity here, basically. So essentially, we're kind of doing this in place. So this should be O of 1 because we are just merging things and putting them into one list, and finally at the very end, our initial thing contains all of our lists. So it's not really O of 1. You are technically increasing a little bit the amount of space you're holding, because if you merge two lists for a while, it will be let's say your array is length n, it'll be 2n or something, or whatever, worst case. But essentially, it's still pretty much O of 1 because, I mean, maybe you could argue it's O of n because you are you are storing some stuff, but I would say not, because essentially you're storing some stuff that's going to be your output, and then you keep you're always deleting the stuff that you don't need. So essentially, you have your entire output in that first part of the array. Okay. But yeah, so that's going to be all for this problem. Hopefully you liked it, and if you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.